Hello everyone, welcome back to my channel. Today we're going to learn how to calculate edit distance between two given words. There are several approaches to take here, one being the top-down recursion, the other being recursion with memoization, and finally we have bottom-up dynamic programming approach, which is by far the most intuitive and efficient approach. Not only are we going to learn how to code this up in Python, but we're also going to learn how to print the actual sequence of moves needed to transform the first word into the second. Now we're allowed to perform the following three operations: delete, insert, and replace. The approach we're going to take is start comparing the strings in the reverse order, one character at a time. The reason for starting in the reverse order is that it makes more sense intuitively when we start filling out the 2x2 matrix in the bottom-up manner. Say we want to transform the word collapse into word flip. Let's represent the two-dimensional matrix M to store the edit distance values for each possible slice of the above two words going from left to right. Let P be the length of the first word, which is 5, and Q the length of second word, which is 4. So goal here is to find the value in the cell 5 and 4, meaning we need to find the value of M5, 4. Since our focus in this video is the dynamic programming approach, we shall start filling up this two-dimensional grid in a bottom-up manner as follows. Our goal is to fill in these 30 cells. Let's start with the first row. If we were to transform an empty string to an empty string, total number of operations required would be 0. If you were to transform just one letter C to an empty string, you would just need the delete operation. If you were to transform the letter C and L to an empty string, you would need a total of 2 delete operations, and 3 for CLA, 4 for CLAP, and 5 for CLAPS. That takes care of the first row. Now looking at the first column, second row. If you were to transform just the letter, if you were to transform an empty string into the letter F, you would need 1 insert operation. If you were to transform an empty string into the letters F and L, you would need 2 insert operations. Similarly, you need 3 and finally 4 to convert an empty string into the word flip. That takes care of the first row and the first column. And in order to fill the remaining 20 cells, we would need some kind of a recursive algorithm, which is what we shall see. So let's start with the words collapse and flip. With the variable I representing the indices of the letters of the word collapse, and let the variable j represent the indices of the word flip in our 2x2 matrix. Our goal here is to find M of 5, 4, M of 5 and 4. So let's start with the last letter of the word 1 and word 2. We have 3 possibilities. We could either delete the S, the last letter of the first word, or we could insert the last letter P from the second word right next to the letter S of the first word, or we could replace the last letter S with the last letter P of the second word. Let's consider each of these 3 cases. If we were to start with case 1, delete S, that would be equivalent to 1 delete operation. So it's going to be 1 plus edit distance of the word clap and flip, because we got rid of the S. So that would actually be 1 plus the value in the cell 5 minus 1 and 4 in the matrix, because we have the word clap, which is 4 letters, so we got rid of the last letter. The flip stays the same. We haven't changed the second word. So it's 1 plus M of I minus 1 and J. Now coming to insert, we're going to insert the last letter P of the second word right next to the last letter S of the first word. This would require us one insert operation, so it's going to be 1 plus the edit distance of the words CLAP, SP, and FLIP. Now, if you notice, there's a repeating letter P towards the end of both the words. So the edit distance of these two words would be same as if we discard the same letter P at the end of the words, because the number of operations required to transform the last letter, if it's the same, would be 0. So it's just 1 plus the edit distance of the words CLAPS and FLI. Which would be the value of 1 plus m of 5 and 4 minus 1. So that would be equivalent to 1 plus m of I and j minus 1. Now, looking at the last possibility of replacing s with the p, we get so we have added a p towards the end. Again, we see that there's a P towards the end of both the words, so that wouldn't add to any operation. It wouldn't add to the number of steps needed to transform. So it's essentially the same as 1 plus the edit distance of the words CLAP and FLI. So that would be 1 plus m of 5 minus 1 and 4 minus 1, which would be 1 plus m of I minus 1 and j minus 1. Now our goal is to find the minimum of the three possibilities. So it would be the minimum of So this is what we're going to be coding to find the minimum of these three. The other scenario would be in case the last letters of the first word and the second word would be the same. It would be basically 0 plus m of I minus 1 and j minus 1. For the same reason as we saw earlier, if the last letters are the same, it wouldn't add to the number of operations required for transforming the word. So it would be just 0 plus m of I minus 1, j minus 1 if the last letter is the same. If not, it would be the one at the top. So let's see how we can code this up in Python using dynamic programming in a bottom-up manner. This right here is our two-dimensional array to store the edit distance values for each cell of the 2x2 grid. So here we are initializing the first row and the first column of the grid that we saw earlier in the video. Now let's iterate through each cell of the 2x2 matrix and calculate the edit distance values using the recurrence relationship that we saw earlier. So here we're checking if the last letters of the two words are the same. If they are, that would mean we wouldn't have to do any operation at all, and the cost of this step would be 0. And the other scenario would be if the last letter of the two words are not the same, then as we saw in the previous slide, we would have to take the minimum cost of the 3 operations. Now let's test our code. So looks like this program is working, as we know the edit distance for the two strings is 3, which would be obtained mainly with the 3 operations. One is replacing C with F, then replacing the letter A with I, and finally deleting the last letter S of the first word. Now what we see here is the 2x2 matrix, the grid, after we have filled out all the cells with the edit distance values using the code that we just created. Now our goal here is to actually print the sequence of moves. So if you look at the last cell, which is the M54, this would be the actual answer to the edit distance. But we actually are interested in printing the sequence of moves. So we start with that and look at the neighboring cells and move in the direction of the least number. So we go from 3 to 2. That would tell us that we would have deleted the letter S. And from here we go in the northwest direction because that's the smallest number. And here the operation that we would have performed is basically nothing because the letters P and the P are same, so we don't have to do any operation. The cost is 0. And next from here we go again in the northwest direction because that's the smallest number. And this tells us that the operation that we would have performed is the the replace operation, where we replace the letter A with the I. And from here we again go in the northwest direction because that's the smallest number 1. And here we wouldn't have done anything because the letters L and L are the same. And finally we again go in the northwest direction. Here we would have replaced C with F. Now let's see how we could actually code this up in Python. So we are going to start modifying the code that we developed earlier. So let us introduce two variables A and B, which hold the same values as the dimensions P and Q. We will also be needing a list variable called actions to hold a sequence of moves needed to transform the first word into the second, which we shall print at the end. So here we have the same letter, as the last letter is the same for both the words. So we essentially have nothing to do here, so we're not printing any actions. So since the value in the cell mi-1j-1 is the smallest, this tells us that we would have done a replacement operation at this step. So here we are noticing that the value in the cell M of I minus 1 and J is the smallest. So this tells us that we would have done a delete operation at this step. So finally, since the cell Mij minus 1 is the smallest here, this tells us we would have done an insert operation at this last step. Now, since the above while loop ends when we exhaust all the letters of either of the two given words, we must check for any remaining extra letters that are either in need of deletion if they're part of the first word, or in need of insertion if they're part of the second word. So let's go ahead and collect those remaining letters and do the necessary operation of either delete or insert. So we have iteratively looped through all the remaining letters and performed the respective actions. So we're modifying our return statement to now return two output variables: the original 2x2 matrix M and the list of actions. Let's go ahead and test this out. Now let's capture both the outputs. So this last for loop right here actually prints out the list of actions to be performed starting from the leftmost letters of both the words. So we're essentially taking all the actions in the list, printing them in the reverse order, because our two-dimensional matrix has the cells going from bottom to the top. Since our program is actually looping top-down manner, we start from the bottom and go to the top. So we have to collect the actions and print them in the reverse order so as to print the actions from left to right. So looks like it's working correctly. So we start with replacing C with the F. We replace C with the F. Next operation is replacing A with I, which is this. And finally we have to delete the letter S towards the end. So this concludes our video. Thanks for watching, and if you liked this video, please hit the like button and subscribe for more related content.